Hello, everybody. This is the re-recording of a talk which I gave a couple of weeks ago at the Institute for Astrophysics at the University of Vienna as part of the colloquium series. The recording back then suffered from some technical shortcomings, so we decided to just do it again. Okay, here we go. I'm Rudi Albrecht. My background is astrophysics, 30 plus years in the Hubble Space Telescope project on the American side and on the European side. Now after retiring from ESA, now with the Austrian Space Forum and serving for Austria in the Austrian delegation to the United Nations in Vienna as a technical expert. In particular, I'm a member of the Space Mission Planning Advisory Group. We are trying to design technical procedures to protect the planet from asteroids. And I'm going to talk about this today. Well, how real is this threat of being hit by an asteroid? Until 1960, which is a surprisingly short while ago, we didn't really make a connection between the meteors, which we see every night, shooting stars, which you see every night, illuminating the atmosphere, and the minor planets, which we assume to be in serene orbits between Mars and Jupiter. Since then, we have come to realize that the near-Earth asteroid population is plentiful and contains thousands of objects, which we keep discovering with robotic telescopes and with space-based assets. Of course, we have to determine orbits in order to assess how potentially dangerous these objects are. This is notoriously difficult because it requires multiple observations and an infrastructure which is capable of doing this. The orbits also are not docile. They change dynamically because the asteroids are small, so they react readily to the gravitational influence of planets, in particular to planets as large as the planet as large as Jupiter. And because of these gravitational interactions, objects can change their orbit and come perilously close to the Earth. Of course, there are other sources of objects other than the asteroid belt between Mars and Jupiter. Let's take a fringes of the solar system, and in particular the Oort cloud, where there are bodies that are left over from the formation of the solar system, and they every once in a while one of these bodies gets deflected into the inner part of the solar system where we are. We also have come to realize that the process of planet formation is still going on. Of course, it was a lot more violent a couple billion years ago, but impact craters, we can see impact craters everywhere, the most common landscape feature in the solar system. And we also discovered that the asteroids played a major role in the history of our planet, in particular the impact, the Chicxulub event 65 million years ago, which thankfully wiped out the dinosaurs and made it possible for mammals to dominate the planet. And we are mammals, so we got our chance. We keep observing major impacts, in particular the one on Jupiter in 1994. That was sort of a wake-up call, but we also discovered that significant events have happened on the Earth. The Tunguska event, and significant events keep happening. Chelyabinsk, in particular, several years ago, and quite recently, an event in the Bering Sea, which was harmless because it hit the ocean. CTBTO stands for Comprehensive Test Ban Treaty Organization, and this United Nations organization has seismometers and infrasound microphones all over the planet, and they are quite successful in recording events like the entry of a small object into the atmosphere. And so this way we are recording a lot of events, more than we expected. We also see such events, like there's an asteroid impact on Mars, which was recorded by one of the orbiting spacecraft. On the left-hand image, you see the landscape before, and then there is the asteroid impact. Here is Jupiter. Those of you who are old enough will remember that this made the headlines all over the place back in 1994. There was a comet which broke up in 21 pieces, and these pieces hit one after another in over a period of a day or so, and pockmarked the surface of Jupiter. Tunguska, 200 square kilometers of forest were flattened by an airburst. Fortunately, there wasn't anybody there. This was Siberia, not a very densely populated area. Russia seems to be a favorite target of near-Earth objects, because in Chelyabinsk in 2014, another airburst of a body about 20 meters in diameter sort of took out most of the windows in Chelyabinsk. The hole in the ice that you see on the lower right-hand panel is what remained of the body. Was a 600 kilo object, which then broke through the ice of a frozen lake and was recovered, in fact. Nobody was killed during that event, but there were lots of people injured. In retrospect, it's probably a good thing that we hadn't discovered this object before, because we would have tried to evacuate Chelyabinsk, and I dare say that people would have been killed because of traffic accidents and other events if we had evacuated. Another comparatively recent example, several thousand years old, is the Berenger crater in Arizona. It's a crater about a mile in diameter. And if you superimpose a map of Vienna on that image, it nicely covers the very center of Vienna all the way out to the Ringstraße. And of course, if it happened in Vienna, it would also devastate an area of about 200 kilometers in diameter. There's a large impact crater here in Bavaria, the Nördlinger Ries. For quite some time, it was not really clear how this particular landscape shape originated, but we found that it is an old impact crater, of course eroded away because of weather and the atmosphere, and more recently agriculture. And we keep finding more and more impact craters, which were not so visible because of the impact of the influence of the atmosphere. This is the situation essentially a couple of weeks ago. The statistics get updated. It is at the same time disconcerting and reassuring, because it shows that while we are still discovering lots and lots and lots of small objects, we seem to have discovered pretty much all the really dangerous objects, 1 kilometer across and more. Of course, the 140-meter objects are also dangerous if you consider the fact that the Berenger crater object was about 50 meters in diameter. What do we do about planetary defense? What do we do about protecting our planet? When we found out that there was a considerable number of potentially hazardous objects, the United Nations got into the action and formed an intercession action team as a result of the Unispace 3 conference in 1999. The Intersession Action Team means that is a team of experts which is outside of the schedule of the United Nations. And the team studied the problem under the guidance of Sergio Camacho, and the recommendation was to form two groups: the International Asteroid Warning Network, IWAN. These are the people who discover those objects, track them, determine their orbits, and, if necessary, issue a warning. The lead organization is the Minor Planet Center in Cambridge in the United States. And the second group is the Space Mission Planning Advisory Group, same page. We are the people who figure out technical solutions to the problem of mitigation. The lead organization right now is ESA. Might change in the future. These groups were endorsed by, in the usual way, the United Nations endorses such groups. It gets percolated up to the Secretary General, and the General Assembly approved those groups in late 2014, and we have been at work since January 2015. So, as I said, IWAN is a coordination exercise, and SMPAG develops actual plans for the defense. NASA and ESA, large organizations, have gotten direct together and formed Planetary Defence coordination offices, as did several other countries, all the countries that joined SMPAG. In SMPAG, the membership is per country. In IWAN, the membership is per institution. We're also holding planetary defense conferences to establish and improve the state of the art every other year. The last one was held in 2019 in College Park, Maryland. This year's conference will be held in Vienna, Austria, but due to COVID, it will not be a real conference. Unfortunately, it will be a virtual conference. The advantage being that there is no personal interaction, but there's an advantage. We have about 2.5 times the number of participants than with a physical conference. We have received 300 abstract submissions, and we expect 700 participants. During every planetary defense conference, we develop a case study, a tabletop exercise, a war game. We take a fictitious object and assume it's on an impact trajectory. And then during the week of the conference, we play the whole mitigation scenario, the warning, the communication, the decision-making process, the procedures that need to be taken in order to actually decide whether there should be space missions and which space missions there should be. And then we discuss the possible results. Primary issues are communication, decision-making, coordination. If necessary, evacuation. It turns out to be very difficult to evacuate certain cities. And of course, there are secondary issues, financial, legal, economic, liability, things of that sort. In order to support this, it's useful to use a real-life example to see whether what we think should happen can indeed be made to happen. So there's an object by the name of the designation of 1999 KW4. It was not on a collision course, but there was a flyby, 1.5 million kilometers, so fairly safe distance, in May 2019. And in the case of an actual threat, what you want to find out about the threatening object will be trajectory, size, shape, composition, structure, as accurately as you can on an accelerated timescale, because there is not a lot of time. We decided at an IWAN meeting to run such an exercise on KW4. Two teams got together, one around NASA, another one around ESA, and we developed fast-track operational plans to observe with the top-of-the-line instruments such as Hubble Space Telescope, the Very Large Telescope, ESO, and Arecibo radar, and other smaller facilities. There was a partial overlap of the teams, which was very useful. We used the already existing communication channels that IVAN and SMPAG had developed. We didn't get all the observations that we planned. After a long time, I wrote the Space Telescope observing proposal again, but this was a very special one. It was a director's discretionary time proposal, because usually it takes 2 years to get observing time on HST, and of course we only had 2 months. So we didn't get, in the end, we didn't get the HST observations because it was considered operationally too expensive. The problem is that not only is the object moving very quickly because it's near, the telescope is moving too. And so you have to worry about all kinds of complex geometric situations. And of course, the telescope moves across the hemisphere in 45 minutes. So it would have been very iffy to try to get that the images. We got the images from VLT. Now it says raw data and reconstruction, and I want to spend a few moments on this image because it shows a general problem. When it says the raw data and the it means the left panel, because that's the raw data, and images overlapped and shifted and as best as possible. What you see on the right-hand side is not an observation. It's an artist's impression based on the raw data. How do we do that? Well, we know the dimensions of the bodies, we know the illumination situation, we know what turns out that KW4 has a spinning top morphology. We know what spinning top morphology asteroids look like. So we just fill in the details, and we get this fantastic image, which looks like an observation. And then people see a real observation, like the one on the left panel, and they say, well, that's no good, I've seen better. But they don't realize that what they saw was a painting rather than an observation. That's a very dangerous situation all over the place right now in astronomy. Okay, we have a similar campaign which ended just recently. As the analysis period is still going on. Apophis, a 350-meter near-Earth object, which flew by on March 6th at 40 million kilometers, so even less of a danger. However, Apophis will visit us again on March 13, 2029. And sure enough, it's a Friday, and the distance will be 40,000 kilometers. Now, 40,000 kilometers is about the distance of the communication satellites in geosynchronous orbits. So not only is this close, there is also a certain probability that it will take out a couple of these satellites. I don't think so, but there is this possibility. And some people are claiming that the orbit might change and it might not just take out a couple of communication satellites, but it might take out a couple of cities on the planet. So we pretended that we didn't know anything about Apophis, and we waited until our assets, ground-based and space-based assets, discovered, quote unquote, the object. And in fact, NEO-WISE, a disused infrared satellite, which has run out of coolant and was recruited as the asteroid discoverer, indeed discovered the object. And we've been following it and done observations just to find out just to determine what we can find out about such an object during the available time. The evaluation is going on right now. Here's the situation. In the center, you see the Earth, 13,000 kilometers in diameter, and here is the belt of essentially the TV satellites, those satellites that you look at with stationary TV and dishes, satellite dishes. Now there's a secondary, not a belt, but a cylinder of geosynchronous satellites, in an oscillating geosynchronous orbit. So you get the satellite moving up and down in latitude. So you see it from south of the equator, north of the equator, depending on where they are. So that is a very important orbit. Now, I have a moving GIF which shows Apophis going by. On the presentation, it's unfortunately not possible, so I have to take my word for it. Apophis will appear around here and then cut through this edge of the geosynchronized satellite belt. So, well, it's a not dangerous. If Apophis stays where we think it will stay, it's not a dangerous, but a significant situation. So anyway, what is it that we can do? Possible actions, possible defensive actions, of course, will take into account what object it is, what type of object it is, what size it is, the structure. Is it a solid object? Is it a rubble pile? Is it a comet? Is it an asteroid? The density of the object. If it's a dirty snowball, you have to treat it differently. Which distance you wanna it is going to be when you get to it with a mitigation mission, the speed that you have to, the delta V that you have to take into account, and how much time you have until it will actually hit you on the head. Possibilities include a kinetic impact. You know, you shoot something heavy very fast onto the object and hope that it will deflect the object enough to change the trajectory in a significant manner and cause it to miss the Earth. Gravity tractor means you park something heavy next to the object, and the mutual gravitational influence will change the orbit of the trajectory of both objects such that the threatening object will not hit the surface of the Earth. You can install a rocket or engine there. The problem there is what do you use as fuel and how do you get it there? Ion beam thrusters is something that's being considered because you get the power from the solar, from the sun, from the solar illumination. You can shine a laser on the surface of the object, get the surface layer to evaporate and produce a reaction and a deflection. Of course, then there's the Bruce Willis solution. You blast it to smithereens with a nuclear device. That has a number of shortcomings. We can focus solar energy on it with huge mirrors with the same effect that the laser ablation might have. Install huge solar sails on the object and use solar radiation pressure to push it out of the way. And if all else fails, we turn around and tell people, look, it's going to hit in such and such area, get out. Issues there are, this needs to be coordinated internationally, obviously. We need to communicate with governments, and in particular, we need to communicate with the public, and we need to be able to make it obvious to people that action has to be taken. And this all has to be done in a legal framework, because there is something called space law, which governs all activities that happen above 100 kilometers. And then there is legal situation on the ground. If you do something and you fail and you cause damage, you're liable. There are two missions that are designed to try the kinetic impact. There is an object, Didymos, double asteroids, 800 meters primary body, 150 meters or thereabouts, secondary body. It's not hazardous. It's a near-Earth object, but not hazardous. And a spacecraft will be launched called DART, Double Asteroid Redirection Test, will be launched to Didymos, and it will hit Didymoon, the smaller object, with a kinetic impactor. So we find out whether it causes any deflection and how much deflection it does cause. The launch is planned for November 2021. And this will be followed up by an ESA mission, Hera, which stands for a Greek goddess, in October 2024. So Hera will go there and see what the kinetic impactor did in terms of effects on the surface, in terms of deflection, definitely, and we'll also do science there. Same page. In same page, as I said, we've been active since 2015, 2 meetings per year, one in February, usually on the margins, almost on the margins of the Scientific and Technical Subcommittee of COPUS, Committee on the Peaceful Uses of Outer Space. And the other one, half a year later, elsewhere. And the elsewhere has been oscillating between Europe and the States. Of course, elsewhere last time around was on the internet. We have a work plan. Well, we have terms of reference, like all such groups. Based on the terms of reference, we developed the work plan. It's been baselined, accepted by the United Nations. We have defined lead organizations for the work plan items. And in particular, we had to establish our position vis-a-vis the Internet Space Law framework, because it turns out that almost everything we intend to do is in conflict with the existing space law. So we formed an ad hoc working group for legal matters with 10 international space law specialists. The report is available. Some organizations have moved swiftly. I already told you about the Planetary Defence Coordination Offices of NASA and ESA. In the US, the Federal Emergency Management Agency, and in Russia, exercises have actually been conducted, tests have been conducted. ESA, DLR, CNES, and ASI are acting active and coming up to speed at this point. Here are the work plan items that we have in same page. And you recognize work plan item number 5.8, which is the title of this colloquium talk, Consequences Including Failure of a Near-Earth Object Mitigation Space Mission. There are others. All the object. Okay, 5.8. All the work plan items have lead organizations, which represent their countries. NASA represents the US, and so on. Now, 5.8. The lead country is Austria. I am the coordinator, and the task lead is Gerhard Trollshagen from ESA, and the Austrian FFG, Forschungsförderungsgesellschaft, is the lead organization. The only work item that does not have a lead organization is 5.10, study of the nuclear device option. Nobody wants to touch that with a 10-foot pole. But we've developed a sort of altogether but anonymous procedure with which we will tackle that. Here is the pros in the same page work plan. Boilerplate, mother than apple pie. I'm not very happy about it, especially since I'm partially responsible for it. This is what you write when you don't know. Before you know much about what you intend to do, just as a general high-level justification of the activity. Here are the major players in task 5.8. As I said, I'm coordinating this thing, and the cast of characters with people and organizations who provided input. The high-level sections are listed here. Mitigation scenarios, the different scenarios in which might occur and require mitigation. The desirable outcomes of such actions, the alternatives and failed outcomes. What happens if we fail, and how do we pick up the damage? what kind of hazards could be in terms of failure, like you hit the nuclear power plant, things of that sort. Strategic planning for mitigation. Obviously, you want to have some resources ready to go, and you might even want to have space assets already in orbit to be redirected, or in some other, not the Earth orbit, but solar orbit, to be ready to go after a hazardous object right away on short notice. You have to sort out your priorities, and then there's communication interface problems, the legal issues I already talked about. Now, the threat scenario. Obviously, if you have a large body, we're going to see it early, which will provide us with a long time during which we can plan, assess, analyze, maybe even send a pathfinder mission to find out exactly what body it is. Like if we find out that, yeah, it's not going to hit this time, but it's going to come again like a prophet. It's going to come again in 10 years' time, and it might hit then. It gives us 10 years to do something about it. If it's a small body, we will not really be able to discover it with a long lead time. But if we have a long lead time, this is the most benign scenario because we have plenty of time, and it's a small object which can be pushed out of the trajectory very easily. Short lead time for a small body is sort of like the Chelyabinsk scenario. It might hit us without warning. The Chelyabinsk object came out of the sun in the early morning and wasn't discovered. For that purpose, we are planning to have space assets away from the Earth, so we can discover objects which, as seen from the Earth, appear out of the sun, sort of World War II fighter style. Large body, short lead time is a killer. It will hit us. The most challenging scenario. And if we want to do something about that, it will require predefined, well-prepared missions with mitigation assets ready to go, sort of like Cold War style. You know, get a warning and you push the button and off it goes. And it might indeed require the nuclear option as a last-ditch effort. So Pathfinder missions are desirable, but I think it's not going to be possible to have Pathfinder missions and mitigation missions in the available time. Slow push and pull techniques, already talked about gravity tractor, impulsive mitigation techniques. As I already indicated, last-ditch solution is evacuation. That includes issues of transportation. How do you get people out of New York City, for instance? Food and shelter, how do you feed them? How do you shelter them? In particular, knowing that they cannot go back after in a hurricane scenario, once the hurricane passes through, you go back, pick up the pieces and continue. If there's a serious asteroid impact, you cannot go back because it's ground zero. There's nothing there to go back to. Safety and security, the resources required. And then, of course, there are groups that require special preparations. Handicapped, elderly, how do you evacuate a hospital? How do you evacuate a home for elderly people? On the PDC, during the PDC exercise in 2019, we had an impact corridor going diagonally across the United States with a final impact. Okay, the original impact was going to be in Denver, Colorado, and we mitigated, and it was a binary object. We mitigated, we deflected the larger object, but the smaller object, 70 meters in diameter, hit New York City. And it revealed that the evacuation of the greater New York City area is nearly impossible, because the situation bordered by ocean and rivers and accessible only through tunnels and bridges. How do you evacuate 10 million people? Where do you get the transportation from to evacuate 10 million people to a distance large enough so they're safe? So an actual possible mitigation campaign will consist of a combination of all of the above. We will not just try one method. We will have several methods ready to go, and we will be prepared to do evacuation if all else fails. Here is the overview of the report. Obviously, I cannot go into all the details in the available time. I invite you to stop the video here and go through the sections and subsections. But what I do want to talk about is the issues of most concern to me personally. They're being covered in the report, but only superficially because it's a report. It's a report with a technical orientation, and the issues that I'm talking about is more of a political and socio-economic importance. International decision making. Is it really going to be possible to impress on all nations of this planet that there is a clear and present danger by something that they cannot see, that they don't even have the resources and the assets to see, that only we scientists tell them that there is, and that it is dangerous? In that respect, it's not at all helpful that almost every other week there is a report in the media saying, well, we're going to be hit by an asteroid. That doesn't help. It's like crying fire. Depending on the object size and the impact corridor, some nations might actually say, not my problem. And even though in our plans, and particularly in the Ivan plans, Ivan has done a very good job on that, the decision-making process is clearly spelled out from the Secretary General of the United Nations all the way down to Jane Doe. It is highly questionable whether this will actually work. And in addition, the military of some large nations might have their own ideas about how to deal with this problem. Interagency collaboration. I've seen some of the problems that occurred between NASA and ESA in the Space Telescope and in the JWST, James Webb Space Telescope projects, and they were quite tedious and took a long time to resolve. Now we don't have a long time. Is it going to be possible to get not only two agencies, but several agencies to collaborate in a meaningful and productive manner? It's highly questionable. And we don't even talk about intellectual property rights and trade secrets. Of course, ITAR is going to be a real problem on the American side. How much information do you want to release for other organizations and countries to get into to be able to contribute? Different space agencies work along different lines. Now, NASA and ESA work along parallel lines, although there are differences. Other space agencies have completely different operating procedures, and it will be very difficult to get these together. And then, of course, some space agencies are more equal than others. I sort of suspect, and that's a personal opinion, that when push comes to shove, the large space agencies will have a tendency to do their own thing without asking around too long. You need to get industry to collaborate for boosters and payloads, and even in a single project, it's very difficult to establish interfaces between contractors and subcontractors. If you try to do this on an international level, it adds another dimension of difficulty. We all know that planes have crashed and spacecraft have malfunctions because of simple things like imperial versus metric units and feet per second versus feet per minute versus meters per second, and this type of thing. and if you try to do that in a hurry, it will be even more important. And as I said, the management methodologies in the US and Europe, in particular NASA and ESA, are quite similar. There are large differences with the management methodology, reporting, controlling, assessing of organizations in other areas of the planet. Something which has not been considered in required priority are socioeconomic consequences. In the end, it could mean that the threat posed during the preparatory phase and the consequences for the economy might do more damage than an actual impact. And the damage will occur even if the mitigation is successful. So that's a catch-22 situation in some way. And I'm going to elaborate on that a bit. And of course, the communication and the interface to the public. We've seen with COVID, with current situation, that it's very difficult to convey meaningful information to the public because, my personal opinion, humankind is basically irrational. Here, the socioeconomic effects. If we assume the possible impact of a 100-meter plus object in 5 to 10 years, UN COPUS will issue a warning, will prepare, will coordinate. IBAN will use the communication channels that it has developed to inform the governments and through the governments, the public. SMPAG will come up with the possible technical solutions. There will be ideally there will be an international decision to attempt the mitigation. The international community will open its coffers and spew out the money to fund this whole thing. Local and regional government will cooperate and will implement the measures that are required. The media will perform in a responsible and informed manner and educate and inform the public. And you notice that I'm being facetious. Space agencies and the aerospace industry will, in a show of unity, converge on possible technical solution, and the population will listen to us, react rationally, and follow the guidelines and recommendations. The COVID experience shows that this chain might not work as expected, will not work as expected. Here is the impact corridor of the hypothetical, somewhere it says here, exercise. Please keep in mind, it's an exercise. And don't show the slide around widely because people might mistake it. Here's the impact corridor, the possible impact corridor of the hypothetical 2019 object. As I said, the initial impact was going to be in Denver. And then because of mitigation action, we extended the impact corridor all the way into the Atlantic for the main object. Now, the main object we got to pass, but the combined binary companion impacted in the end where's the cursor? Here it is, in New York City. So for a number of years, this whole area was under threat of annihilation. Do you really think that people are going to take this sitting down, patiently waiting for us to tell them, yeah, evacuate, or no, continue life as usual? All kinds of things might. As I said, the initial impact corridor will be quite extended. Was quite extended. It ranged from the Pacific across the United States to the Atlantic, but then we narrowed it down for the purpose of this exercise. It also will depend on the object type. Is it a dense and solid object, or a rubble pile, object nature, single binary multiple shotgun blast, the impact velocity, the impact angle, all of this plays a role for the possible consequences of an impact. Location, on land, crater, in water, crater too, but tsunami, atmosphere, a blast. The impact results include all of the above. as I said, in 2019, we lost New York City, and with it, we lost Wall Street. Now, everybody knows that this will have consequences for the economy. Now, the PDC assessment stopped right there, a statement saying we lost Wall Street. So then I contacted Mohammed Dor of Brock University in St. Catharines in Ontario in Canada. He was the only person who I found in the literature who did a case study. Usually, impact effects include nuclear winter and transportation problems and infrastructure problems, power outages, maybe nuclear radiation problems if you hit a nuclear power plant. But hardly anybody had done an assessment on the economic impacts, on the financial consequences. So Mohammed came up with these 5 scenarios: damage up to 5 billion, fatalities in the hundreds, tens of thousands injured, local infrastructure damaged. Example, 1989 San Francisco earthquake. Recovery is months, can be handled by one country. Next step up, 20 billion damages, tens of thousands of people killed, hundreds of thousands injured, local infrastructure destroyed. Example, 1995 Kobe earthquake. Recovery time is years, can be handled by one powerful country or by several countries if it hits a not so potent country as Japan is. Now, number 3, several hundred billion in damages, loss of a major city like San Diego, 10 to the 5th, hundreds, up to 1 million fatalities, millions of people injured, millions of people homeless, loss of regional infrastructure, loss of regional governance. And the recovery is many years, and it requires international collaboration, especially if it hits a smaller country. And number 4, even more, if it hits New York City, like the PDC 2019 war game. And of course, there we are talking about not only domestic, but international consequences, and the recovery will be decades. It will require global collaboration. Then we can talk about the loss. We can take the example of the loss of a whole country. Financial assessment here is impossible. For instance, Switzerland or the UK, the recovery will be many decades, and again, it will require global collaboration. And then, of course, major impact, Chicxulub type, Nördlingen impact crater type, all bets are off at that point. Now, what consequences do we expect for the economy in the pre-encounter? I call it encounter. I don't call it impact because ideally there is not an impact. There will be a flyby, but it will be an encounter. And the uncertainties associated with the encounter have impacts on several areas. For a working economy, you require these elements. You require production units, and the question is, will they continue to be available? For how long? Will the workforce be available, or will they not move out of the impact corridor? How long will they stay? Will there be people to perform maintenance work on your production units? Will there be a delivery chain of spare parts? Will the power be available? Because who is going to maintain a power plant which will be destroyed in 2 years? And for how long? Of course, you need to communicate with the customers. Will there be customers in the first place, or will consumer priorities will not have changed? Who is going to buy shoes if there's an impact pending? So will there be demand for certain goods to begin with? Which communication channels will there be available? Will TV stations not shut down in time because either because of lack of maintenance or because of economic financial considerations? Most payments, they are electronic. How long will the electronic system of financial transactions be available? Will the currency, in fact, remain stable? The US dollar probably will, depending on the size of the object. The European euro probably will, but will the currency of some smaller countries, will it remain stable? Will there be serious devaluation, in other words, inflation of the value of certain currencies? What about cryptocurrencies? Will the bubble burst? Will people start doing barter trade? And what will this do to the tax base? What if it happens in developing countries? Will there be corruption, fraud, black markets? Yes, there will. And what impact will they have? Same for the banking system. Will it be reliable? What about the cash situation? People will want to get cash because they are afraid that their credit cards will not work. So everybody will go out and will turn their savings, and maybe they get a loan, try to get a loan, and turn them into cash. Will people continue to accept computer payments? Will there be anybody out there to give you a loan? If there's a high chance that you will never be able to pay it back because your collateral will be destroyed. The investor confidence, who is going to invest anything in an impact corridor stretching across the United States with a good chance that it will be destroyed by an asteroid? Will anybody issue insurance? I think that's going to be a very difficult situation. Hedging. Some people might buy or invest in assets that might survive, get them cheap, and if they survive, sell them at a higher price. Short selling, okay, back to short selling of stock and bonds. Predatory buying, suppose you are a not so friendly government and you find out that real estate prices have just dropped to zero in large parts of the United States because there is the serious threat of an asteroid impact. What do? You buy up this cheap land. Well, if the asteroid hits, okay, you're out some money. If it doesn't hit, you own a considerable portion of the United States and you do what you want with it. Will there be fraud? Will people sell you asteroid insurance? What about fake news and rumors? How will they impact the economic situation? Because people react financially and as far as investment goes to news and to fake news and to rumors. Will the markets continue to work? Will there be trading in stocks, commodity, real estate? Of course, already said that the real estate prices in or near the impact corridor they've got to fall all the way to zeros, which means that mortgages will default, which means that banks the banks that issue such mortgages will have a real problem. We'll see the same consequences that we saw in the 2008 prime rate crisis. People might sell off assets and try to buy durable goods. Of course, that will change the price of the assets. It will get them lower, it will decrease them, and it will increase the price of durable goods. Who is going to be interested in stocks of Nike? So forget them. Some commodities will spike, gold certainly, and maybe some others. Derivatives like futures contracts, they will behave erratically. We've seen it with COVID, when everybody thought that, well, initially stocks fell, and then because of all kinds of combinations of circumstances, in particular the prime rate situation, they behaving erratically against expectations. Trading will most definitely have to be stopped at some point. The legal system, rule of law, enforcement, will it continue to work? For how long will it continue to work? Will law enforcement agents be available in the first place, or will they not try to get out of the impact corridor? And the other criminal activities for like fraud, embezzlement, loan defaults, and so on, will they continue to be prosecuted? Who is going to do it with people trying to leave? And with people having left, will there be looting and vandalism? But there probably will be. We see it during every hurricane evacuation. What do the central banks do? What will the Federal Reserve in the United States do? Will the currency remain stable? Will the national authorities be able to support, to shore up the currency? Our currency is what they call fiat money. So there is no, it's money because somebody decided that there shall be, the greenback shall be worth something. But it's not backed by commodities like it used to be, like gold. It is backed by the confidence in the financial construct of the issuing country. Now, as I said, Europe and the United States will probably be able to uphold the confidence, but some other countries will not, depending on where the object will hit. And it's all being tied together by information technology. So how long is going to be how long is the internet going to be available? And will it be saturated at some point? Will there be priorities given definitely to mitigation actions? But what about financial priorities? Will there be cyber attacks utilizing this very dynamic situation? The problem is, since the economy depends on so many different factors, there is no guarantee of stability. But there are major reasons to assume pre and counter consequences. So nothing has happened yet. Situation unchanged, except that we scientists told the population in 5 years from now it will impact, and if we mitigate, it might impact in that corridor, especially in the case of the impact of a large object, which might be detected years ahead of time, and for which the impact probability increases, but the location is uncertain during this time. And as I said, the catch-22 situation is that additional uncertainty will definitely be introduced by a mitigation mission, which might only be partially successful, but which will change the impact location in unforeseen ways. So instead of being certain that Denver, Colorado will be hit and we evacuate and rebuild, we now are facing a situation by which all cities between Denver and New York City might be hit. So a good example is 9/11, during which we lost Wall Street for a few days, for about 1 week. But this came out of the blue. It's like a small object, short lead time. For about 1 week, it was not clear whether the attacks might continue. In our case, in the small object, short lead time, it might be very similar. This might be just the first object of a series of objects. So in order to shore up the currency, the Federal Reserve immediately injected 100 billion of liquidity per day during the 3 days following the attack. Now, the US can do it, Europe will do it, some other countries cannot. Gold prices spiked, oil prices spiked, gas prices in the United States spiked briefly. Currency trading continued with the US dollar falling sharply because Wall Street was lost. The next day, European stock markets followed, but and of course, stocks in less powerful countries, they plunged, but they recovered. In Mexico, they actually had to hold trade. They recovered. The total cost is hard to estimate. There were immediate costs, like the cost of the building. Then there were secondary costs, like all the activities around And then there were long-term costs like to install the Department of Homeland Security. And of course, Iraq was invaded. And so the total cost was as high as 10 trillion. The total cost of the total immediate cost and the follow-on cost, including the invasion of Iraq and the war on terror, which is still going on to some extent. COVID. Here is an estimate of the cost of COVID given by the Journal of the American Medical Association as of October 2020. So as you can see from the number, these numbers are in billions. The cost is considerable. Now, I think this is conservative. The long-term cost is going to be much higher, immediate and inferred secondary cost. Briefly, and to finish up, communication issues. As I said, this chain of iron informing the United Nations in a responsible and considered manner, and the United Nations informing the governments in a responsible and considered manner, and the governments informing the media in a responsible and considered manner, and the media informing the public in a responsible and considered manner, it's not going to work. We learned that, we're learning that right now with the COVID pandemic. Mitigating the asteroid threat will require the cooperation of parts of the population of either a large country like Europe or the United States, or a large part of the population of the whole planet, at least in a cooperative manner, to synchronize and coordinate the mitigation actions. And as we can see from the reaction of the public to the measures recommended by international bodies like the World Health Organization, in the case of the COVID threat, that doesn't work. So we have to expect serious problems. You know, with the COVID, you cannot see the virus, but you can see the consequences of the virus. With the asteroid, you cannot see the asteroid, and you cannot even see the consequences. It will all happen in the future, and there will be no shortage of people saying, well, this is all made up and conspiracy theory. And what we see in the case of COVID is that after the initial period of cooperation, the willingness to follow rules and guidelines decreases dramatically, up to and including demonstrations against government, against measures that were introduced by the government, which are going on right now in the case of COVID. We might see the very same thing in the case of a credible asteroid threat. And the obvious cause is the difficult communication situation in combination with some not so pleasant aspects of human personality and character. And as I said, we have to expect that similar chain of events will happen during the asteroid threat. So the general knowledge of the public, the level of knowledge in the public with respect to the virus is limited, and it was very hard to educate the public as far as the virus was concerned, and to when it came to introducing measures like wearing a mask, wearing certain masks, doing and following certain procedures of hygiene. It was very hard. In the case of asteroids, the general knowledge is essentially zero. People don't know anything about asteroids except that they exist, and except the fact that scientists claim that they exist. Excuse me. So it is not possible to rely on the ability of individuals to evaluate the relevance of news items. So the official news items, they tend to be factual and boring. So the media take it upon themselves to interpret the news bulletins and make them more readable. Certainly, they have to be translated in other languages. And what the media do is they try to attract attention. And in order to attract attention, they often focus on controversy and antagonism in order to maximize public response and therefore profit, because the public then buys these products. This produces a cacophony of opinions, lots of people talking, having different opinions, one person, 5 opinions. And of course, the postings in the social networks, they tell their own story. Take the typical discussion, TV discussion. You have 2 groups of, you have the mainstream scientists, they have one opinion. And then there are a couple other people with different opinions. And in the discussion on TV, you will have one representative of the mainstream opinion and one representative of the dissenting opinion. So they will have the same perceived weight. That's a very dangerous situation. Information, as a matter of principle, can be characterized in many different ways. Like, for instance, the description of an earthquake by geologists will be totally different from the description of the same earthquake by a medical doctor or by the owner of a destroyed building. And guess which story the media will latch onto? They will latch onto the story of the owner of a destroyed building, followed by the medical doctor. And the geologist will, the geological facts that they measure is the strength of the, that they mention is the strength of the earthquake, and that's it. And if in a situation which is developing rapidly, there will always be divergent information, either legitimate, because different scientists interpret different facts in different ways, in a meaningful way, in a responsible way, like the criticism and the review that happens during the peer review process of a scientific paper that was picked up in the case of COVID by a German tabloid and interpreted as a major fight among virologists. And there is also a certain tendency of some people to attract public, to become publicly visible. And the example is, if you agree with Dr. Fauci, it has no benefits. There is no consequence of that. If you disagree with Dr. Fauci on TV, in public, you'll get on TV, you'll get on CNN. And some people will do everything to get themselves on CNN. The situation will be made considerably worse by those people of questionable intelligence who believe in conspiracy theories and who follow and actually create fake news. Humans, unfortunately, have this tendency to do that in situations that they either cannot comprehend or have a problem refusing, have a problem accepting them. This guy here, he doesn't represent of 50% of the American population. He probably represents like 5% of the American population, but the other 45% of the 50% tolerate him and to some extent admire him, and that's very disconcerting. Now, over the centuries, this has happened all over the place. Perfectly natural events were interpreted as acts of God or gods, and punishments inflicted by gods. And minority groups were blamed with disastrous consequences for these minority groups. Now, we do have better education, and scientific facts are more readily available these days than they were in the past. But modern society still suffers from this tendency. There's still lots of people around who are not willing to accept scientific facts. Google lists about 60 conspiracy theories ranging from the relatively benign, like Area 51. This is the area in Mexico where aliens, where the US government keeps aliens imprisoned, flat Earth theory, to the relatively dangerous, like anti-Semitic and deep state conspiracy theory. And then there are the dangerous people, hate groups. There are hundreds of them. It's very entertaining and disconcerting, in fact, to surf the web and find out who these are. These are individuals who are ready to do violence based on all kinds of irrational facts, like and factors like culture, nationality, religious belief, gender, sexual preference, and others. There is every reason to believe that some of these groups, or some if not all of these groups, will try to instrumentalize the announcement of a possible impact to further their agenda, just like right-wing groups are usurping the demonstrations, the anti-corona demonstrations, to further their cause, the right-wing cause. In Europe, at least. I'm not so familiar with the situation in the United States, but in Europe, we get right-wingers marching against corona measures just because it's something that they can do against the government, against the democratically elected government. A surprising number of individuals find strange satisfaction in generating misleading and counterproductive messages, and the internet is full of those. Questionable agenda of some political forces, domestic and international. If it's to their advantage to spread ambiguous information, they will. No, of course, nobody will advocate to hate asteroids, but there's a strong reason to assume that some groups will claim that this whole thing is only being made up by George Soros or by Bill Gates or Elon Musk or whoever, Rudi Albrecht, in order to, in the end, subjugate the people and get some kind of questionable benefit out of it. And I think it's inconceivable that hate groups like the Aryan Knights of the Invisible Empire, what a name, will peacefully collaborate with the new Black Liberation Militia just because we scientists tell them that this is the right thing to do. Not a chance. So here is the situation, and I will leave you with that because apparently it's happened before. Okay. Thank you for your attention.